Well, it's time to start working with our project to actually see in action the performance problems and understanding why we need to solve them and how. Just a summary, we are doing this for the user, and that's because it will increase conversion and that will increase business opportunities. That's why we're doing performance, okay? Just remember that. So this is what you get from the repo. You have on the material section, you have the slides in PDF and the ebook that I promised, a copy of the ebook. And then we have a very basic Node.js with Express.js server. So the only thing you need is to install npm install. You run npm install over the folder, and it will work. And then you can start the server with npm start. Nothing really fancy. It opens a server on localhost 3030. You can change the port, and you will see something like this: Front-end Museum. It's a front-end museum. Okay, so it's a very basic HTML website, but if you run it, it feels slow. And you can see it's taking its time to load, and of course forcing in this code a couple of problems. And if we try to create a Lighthouse report on it, now maybe it's time to understand the mode of Lighthouse. If you have ever been playing with Lighthouse in the past 5 years or so, probably you haven't seen that because that's kind of new. Navigation is actually the default option that we used to have in Lighthouse. It's actually going to reload the page and measure the performance of the whole navigation process, the load process. Timespan, when you do timespan, it will make analysis over a period of time when you interact with the content. For example, I can start a timespan, and then I should work with the app, like interact with the app, select, click, wherever your app is doing, and then end the timespan, and now it will give you some insights and ideas on performance issues that you might have over that interaction that you saved, okay? So that's the one. If you want to create another report, you have the plus sign there, so I create plus sign, and a snapshot is just going to take the page as it is right now, so it's not going to refresh the page, okay? And that's useful for single pages applications where you are like in a deep link and you want to test how it looks like, the performance of that particular moment of the app. So you go to that particular moment of the app, to that state, and then you create a report on a snapshot. Most of the time, we start with navigation. That's what we want. And it's going to restart. You see the reload operation. And the slower your website, the slower you will get the report as well. And it will give me the score and also a list of problems that it has found. So I'm getting 60. It can be worse, okay? I've seen websites with 2, the score of 2 of 100, okay? 2 of 100. So 60 is kind of but you can see it's a very simple HTML, and we are still having performance issues. So we see a lot of white, until we see something. So we will see how to solve the problem, okay? So the first Contentful Paint, it's in almost 4 seconds. That, I guess, we can try to see that in action, but it should be that image, right? So it seems like the largest part of the initial page. So it has performance issues, and if we go to the Network tab on Chrome DevTools and refresh, we can see the waterfall chart here. Okay, so that's the waterfall chart, and we can see that's the HTML. Always the first request is the HTML, it's the document, and well, there are some exceptions on that, and then we start downloading more assets. We can try to do this like this. So we have a JavaScript, a CSS file over the timeline. Okay, makes sense? Cool. Now that we have that, let's go back to the slides and let's understand the browser, how the browser works. I'm not going to get too deep here, but enough to understand web performance solutions or tips and hacks. So why we are going to do some things. So what happens when we browse the web? So we need to talk about the network layer quickly. We're not going to get too deep into the fundamentals of networking, but at least basic enough to understand what's going on. The parsing part, when the browser is parsing the HTML, the resource discovery phase, where in this case the browser is discovering other assets, other resources that are needed to render the page, JPEG files, JavaScript files, style sheets. Then the way that the browser has to prioritize elements, so it needs to download 10 assets. Which one should download first? Well, there is a process for that. And then layout and paint, and we won't get too deep into layout and paint. That has to do with how the browser works with the GPU and measuring stuff and things like that. So, don't worry, that blank page means that I need to get out of the slides and make a quick text file. We're going to do this in a simple, easy way. So, when you type www.frontendmasters.com, what's going on? Let's say it's the first time. It's the first time you're going to that website. The first step, and I'm talking about the network layer, is a DNS query. Actually, your browser needs the IP address of the web server for Frontend Masters. That's using a TCP connection, so you need to connect to your own DNS server that goes to check into another DNS server. There is a process there. I'm not going to get too deep here, but that DNS query might take, without taking latency in consideration, might take 100 milliseconds. So in average, it can be more, it can be less. So 100 milliseconds without latency. So if you are in 3G, we need to add the latency. Remember the latency? So when we have the IP address, we need to make a TCP connection. Actually, we're going to start the HTTP connection, okay, but it starts the TCP connection. That I'm not sure if you have experience working with the network, but there are at least 3 messages that we need to send and receive from the client to the server that goes, right? So that might take another 100, 120 milliseconds. We still didn't get any HTML. Actually, we didn't request yet the HTML. We are just opening the connections, and now we are working with TLS. What's TLS? SSL, HTTPS. So we know that today we are all going to HTTPS, right? Do you know why? Why every website today should be HTTPS and not HTTP anymore?
It's encrypted by default.
It's encrypted by default, yeah. But it was encrypted by default in the 90s as well. And we didn't push every website to be HTTPS. Is that because we didn't care about security there? Then? So does it make sense? So the question is, yeah, it's more secure. Okay, cool. But the same thing happened in the early 2000s, even 10 years ago. Why is that we weren't actually pushing every website into HTTPS as today? Is today's security more important? You may say, yeah, but we have more bad actors, maybe, but that's not actually, that's the excuse, not the real reason of why we're doing this. Yeah.
HTTPS allows for HTTP2.
HTTPS allows for HTTP2, but that's a consequence, not a cause. So the question is still there. So why HTTP2? In fact, let me tell you this. HTTP2, the second version of the HTTP language that we will see in a minute, the spec doesn't require HTTPS, but all the implementation from the browsers are requiring HTTPS. So it's not really a requirement from a spec point of view, from a protocol point of view. So what's going on? So I will simplify this really quickly, but let's take HTTP2 as an example. And this has to do with a lot of research made by Google. Google realized that there are a lot of actors in the current backbone of the web that are not following the HTTP protocol rules. Example, let's say we create today HTTP 14. Okay? So HTTP 14 means it's a TCP request that in the header somewhere it says HTTP 14. Well, the spec says if you're making a proxy, a router, so you're making a device that receives a packet and sends the packet somewhere else. When you receive the packet, if you want to open, let's say you want to open that, and you see a protocol that you don't know, the rule is to just forward the packet. You are not responsible for making a decision. But there are a lot of routers out there that says, oh no, HTTP 14, no, that's probably wrong. So let's discard the packet. I'm simplifying this, but just to give you an idea. So with that in mind, we had a problem. To evolve the protocols, we need to change those routers, and we don't know who owns them, where they are. They probably has written 15 years ago. Based on Google research, on some countries, let's say China, there are a good amount of routers doing that. So we realized that to improve the web's protocols, we need a way to bypass that without changing those routers. And the way to do that is to encapsulate those packets into something that the router cannot read. And that's HTTPS. So HTTPS, because it's encrypted, any proxy in the middle cannot actually open the package and see what's inside. And they just forward the packet. So that's the reason why we are pushing this harder, or we have been pushing this harder in the past 6 years. Not because of security. Yeah, we had the nice thing saying, hey, it is more secure, but it was before as well. Okay? But that's why browsers today, if you're in a website that is not secure, will give you a warning. Hey, this is a HTTP, we have a problem, you don't send any form. Yeah, that's a security thing, but there is another problem behind, and it was performance, because we couldn't move the protocols further if we left them as they were. Okay, does it make sense? So that's actually the reason why we need HTTPS. And why not every website 10 years ago were HTTPS? You know one reason? There is one big reason of why. 10 years ago, only 5% of the websites were HTTPS.
Changing protocols is hard?
No, because they're not actually changing protocol. You're just adding something on your web server. What's that something? A certificate. And that certificate was expensive. Originally, I remember in the 90s, my first HTTPS certificate that I bought for a customer, it was, if I remember correctly, $950 per year. So yeah, you don't want to do that. Yeah, maybe 10 years ago that was better. We had other companies offering also certificates. Maybe you can get one with like $30 per year, but still it's something you need to pay. But because that was a problem and we all wanted to push HTTPS, that's why there was a new organization that you probably know. It's called Let's Encrypt. It's a non-profit organization created by the browsers and other companies to push HTTPS. Those are the founders and sponsors. They want to push HTTPS, so they provide you with a free SSL certificate. That wasn't possible before. Okay, now that was a parenthesis to understand why we need to move to HTTPS. Okay, anyway, because we need to move to HTTPS, let's go back here. We also need to make a process to negotiate public keys and private keys. That might also take 150, and it depends on your servers. So far, we haven't even request defined. That's the next step. An HTTP request. That is to, hey, I'm the browser. Now we are securely connected. I have your IP address. I have a TCP connection open with you. Now I'm going to request a document, like your default document in the root, the index.html. So what's the problem with that? So far, we have spent, without taking latency in consideration, we have spent how much? 350, almost 400 milliseconds. And for our largest contentful paint, we have a budget of 2.5 seconds. So yeah, that's a lot. we are taking a lot from our budget, 10%. We have just wasted, invested 10% of our budget just in the network layer. So now that you understand that we have a budget, that is a limited budget, as any budget, how important is just 100 milliseconds? Because sometimes you say 100 milliseconds, yeah, but now we are adding 100, 150, 100 from here, from there, and we need to reach our goal. The user should see the largest contentful paint within 2.5 seconds. And this is without taking cellular network latencies in consideration. If you are on a 4G network or 3G network, you may add 80 milliseconds on each of those requests. Okay, makes sense? Well, what else? We made the request, and then the server has to process. That is what is known as the backend time. If you are just requesting an static HTML, that's easy. The server just go to the file system, gets the file, and give you the file. But anyway, that might take 200 milliseconds. If you have a server-side library, PHP, Java, Node.js, Next.js, well, that might take 500, 600, just to get the final HTML that we are still using from our budget. Now we have a siren, so let's wait. Okay, it was easy.
I think we're good.
When the server is ready and it has the string or the bytes that it wants to send, it creates an HTTP response that goes over the downlink. In fact, we didn't mention this, but this is using the uplink of your connection, and this is using your downlink. You know that when you have a connection, a network connection, you have an uplink and a downlink connection. Typically, the uplink is slower in terms of bandwidth. It has less bandwidth. Okay, so that's another thing to have in mind. So then, the HTTP response appears, and then the browser starts the HTML parsing, the document parsing. So it starts reading the HTML. Oh, we have a tag, a head tag, we have a title tag, and it's creating the DOM on the fly. And while it's finding some other resources, it's creating that idea of that we mentioned here is the discovery phase. So it's a resource discovery. So it's discovering resources. Oh, I need a CSS. Oh, I need a web font. Oh, I need an icon. Oh, I need a PNG. Okay, and it's creating a table. And on that table, it's also adding it's setting a priority for each resource. Okay. And after that, at one point, the browser decided to render. That inside it has more steps, such as layout and paint, that we won't get too deep today on that. But that means that a lot is happening here. And when we understand what's going on, we can make better decisions on what to do and how. Remember, my goal is for you to feel bad today about how you are doing things. And you need to feel the pain that is here to get. We have a very limited budget. And we need to achieve the goal that in our website we are not achieving, because let me close this. When we were here, let me see if the lighthouse is still there. Yeah, we are not achieving largest contentful paint in 2.5 seconds. In fact, it says 7.5 seconds. So this is pretty bad, even with a simple website. Yeah, I pushed a couple of weird things in that code on purpose that we will see in a minute, but that's the goal. Okay, once we understand the process, we can make things better. Do you have any question? Any question at this point? So both the HTTP request and the HTTP response both have a header and a body. For the request, the initial request, the body is typically empty. So the header is text that the browser is sending to the server saying, hey, I'm Chrome, I want that document, I accept PNG files, JPEG files. So it's a lot of information that the browser is sending to the server. And when the server is responding, there is a header. In that header, for example, the server adds the status code, such as 404, 500, 200, saying that, yeah, I have the file you requested, I don't have it, or I have an error, and the body, that is the actual data that you requested. Okay? When you're in the network layer within Chrome, you can click on each request and actually see the headers. So if you go to the headers, we have, let me increase the font size a little bit for you. And we have the response headers and the request headers. So this is going right now to request the HTML. All these strings are sent through the app link to the server, and then the server responds with that information apart from the HTML. That's how that works. Just have that in mind for now. Okay. So HTTP has several versions. I'm not going to even mention HTTP 1.0 because it's been not deprecated, but it's not in the wild, and it hasn't been in the wild for probably 15 years. So HTTP 1.1 is still 15% of the or 20% of the market share. In fact, how can we know the percentage of network HTTP-based network communications in HTTP 1.1, 2, or even 3? One resource of information is a website known as HTTP Archive. Not sure if you have heard about HTTP Archive. Have you heard about archive.org? That's the Internet Archive. Well, based on the Internet Archive, it's actually saving resources, the HTML, CSS of websites. So you can see here how Google was like 20 years ago. Okay, so you can actually see how Google was. You can see the website. Okay, but the Internet Archive is not saving the HTTP headers or performance data. Okay, so that was the homepage. I remember that one, but the logo is not there for some reason. Oh, there it is. I used that version of Google, by the way. But it's just the contents of the file. Well, HTTP Archive, it's actually saving not the file, but all the headers, all the information that is useful for example, web performance or for analysis. So here, for example, we can get reports about the loading speeds of websites. That's how we know how performance is doing over time, generally on the web. There are a lot of reports here, and from here we can also check, for example, how many, I think it's here in state of the web, yeah, how many requests do we have on HTTP 2? So this is how it's getting better over time, okay? But we are right now on around 68% of the web is on HTTP 2. Okay, that I will explain what that is in a minute. HTTP 3 is 20%. And there is still some network connections on 1.1. So on 1.1, the biggest problem, that is not a problem today anymore because we don't have so many connections on this version. We have one request per TCP connection. So which means that if I call you, I can only request you one file over that call. So if I want to download in parallel more files, like I want to download PNG files, CSS files, I need to make different calls. I need to have 8 phone devices, I'm sorry, and then call you 8 times. I need to open 4 TCP connections, okay? Which is kind of a problem. It was a problem at the time to download several resources in parallel. This version accepted gzip. I'm not sure if you know this, but when you're browsing the web, if everything is set up correctly, you are downloading zip files, at least for the HTML, the CSS, and the text-based files. Everything is zipped. So then the transfer part is smaller. HTTP 2 added performance from scratch. HTTP2 came from an experimental protocol created by Google with the name Speedy, and that became the standard then, that was created with performance from scratch. And here was the moment where we realized that we had to switch to HTTPS, because if not, we cannot change the protocol safely. HTTP2 added header compression. So those headers that I mentioned before are compressed as well, not with GZIP, with a different algorithm. But on HTTP 1.1, they were not compressed. And the space that headers are consumed is typically around 1K. So you have 1K up from the request and 1K for the response, even if it's an empty response. So you have like 1.5 to 2K kilobytes per request wasted just in metadata, not in the real data. Well, HTTP2 is compressing that, so it's not a problem, and also has something known as TCP connection reuse. It opens just one TCP connection, and over that connection, it can send and receive several files at a time. Okay, using different algorithms, it doesn't matter. But that's, have in mind that HTTP2 is much better for performance. And now we have HTTP, before that, HTTP2 is TLS based only, as we mentioned before. Today, it's good compatibility. You just need to upgrade your servers or use a CDN. Okay, it works with upgrading connections. So the first connection, we start with HTTP1, that is a standard, and we ask the server, hey server, I accept 2 if you want to upgrade. And the server will say, okay, let's upgrade, and from now on, it continues in 2. If the browser is not supporting 2 or the server is not supporting HTTP2, everything is done over HTTP 1.1. And HTTP 3, it's exactly the same as HTTP 2, so it's the same interface, but instead of using TCP, it's using UDP. Does anyone know what that means? You had the face of, I know it, but I'm not sure.
Like universal digital packet or unstructured digital packet?
No, it's not about unstructured, but right about that, I mean, I'm not talking about what the acronym means, but what's the difference between TCP and UDP?
Yeah, it's packet based as opposed to like
Both are packet based.
But it's asynchronous. That UDP doesn't necessarily have to maintain a handshake continuously.
We are close, but I'm not sure I like the answer.
Doesn't UDP allow dropping some packets? Like you can lose some data in the process?
Yeah, we are close. It's not that it's allowing dropping the packets, but actually what is happening is it's not detecting if packages are being delivered or not. TCP is guaranteeing that packages will be delivered, and if it's not, I mean, it's checking that every packet is getting into the destination, and if it's not, it's retrying.
Is it the ordering? Is UDP not necessarily in the order that it's supposed to be? Like
that's another thing. So actually, TCP is guaranteed the order. So actually, because when you're sending messages over TCP, for example, the message typically is split in chunks, in packets, and they go over the network, and they are traveling around the internet, and they might arrive in different orders, or maybe one packet is lost, so that's why TCP is managing that. UDP is more that, okay, I'm sending this, I don't care, okay, I will continue my job. HTTP 3 is based on UDP. And maybe you're thinking, well, but what happens then? My packets will not get into the destination. Well, actually, there is another protocol on top of that that is a thin layer that is much performant than TCP that makes things faster. Anyway, the only thing that you need to know is that it's faster, and it's something that you have to support in your server. If you don't want to or don't have the resources to do that, maybe your infrastructure team is telling you, we are not going to do that. The solution you have is add a layer on top, such as Cloudflare. There are companies, free or paid, where you add like a front end to your website. They offer HTTP 3 to your users, and they contact you over an older protocol. Cloudflare is one example of that. Okay? Anyway, Those are the versions of HTTP available today. Another thing to know about the browser, because we are talking about how the browser works, is the cache. So typically, or originally, we developers, we hated the cache. So it's like, in fact, let me see if it is still working. It was working like a year ago, or in the past 10 years. When you were doing a search on Google, and you search, for example, PHP no. Let's see, yeah, there it is. Now it's the second one. It was originally the first one. No cache. So it's like the most search thing is how I disable the cache. So you use a backend server no, and the next thing is I don't want a cache. Why? Because we don't manage the cache initially, so we are scared of things we don't manage. So it's like I don't know what's going on. So I don't know if it's a cache problem. This is browser. If my browsers are caching data that I don't want, then I'm not going to send the user the right message or the right content. So we typically say no to the cache. Well, we need to make cache a friend. Okay. So how the cache works. And typically we will focus on caching on the resource discovery queue. Okay. So we have a resource discovery queue. So now the browser is parsing the HTML, but now the browser knows that it needs to download a CSS, an image file, a JSON file, a SVG file. Okay, it has a list of elements to be downloaded. So what it happens is that in this case, the browser will check the cache to see if we have a version of that file or not. And how does that work? Do you know how that works, or how the cache works? So is the browser making the decision about what to cache and for how long? Who makes that decision? Well, actually, us. And the problem of not knowing the cache is that we are not making any decision. Okay, so actually we will define cache headers per file. Sometimes it's not per file. We define it per type of file. So for all the CSS files, or for all the CSS files in that folder, etc. We can define an absolute. Oops, have a typo. So let's do it again. Absolute expiration date. That was actually set in the original 1.0 HTTP protocol. We can set the relative expiration date. I will give you examples in a second. That was added in 1.1. And there are more specs, more values that we will see during the rest of the day. But the original ones are these two. Absolute expiration date means when the server is giving to the browser a CSS file, in the headers we add one that says that CSS file expires May 21 of 2024 at 4 p.m. Pacific time. Then the browser will save the file in the user's local storage, in the user's device, let's say until that date. It doesn't work like that, but okay, makes sense. And relative expiration date means I want this file will last for an hour, or for 2 years, or for 1 month. And then the browser will calculate the real expiration date. Okay? So now, let's say the browser needs a resource. So first, it checks the cache. It can be a cache miss or a cache hit. A miss is it's not there, and that's simple. If it's not there, okay, we go to the network as usual. Business as usual. If it's a cache hit, okay, it means the file that we need is in the cache. Okay, so it will verify if it's expired or not. Can be, let's say it's expired, it's not expired. If it's not expired, we will say, well, let's use it from the cache. So we use the file from the cache. We don't go to the network. So we don't have the HTTP request. We don't have the latency for that request. We don't need to wait for the server to respond or to get the bytes. Okay, we have the file. What happens if it's expired? So we have the file, but it's expired. What do you think that will happen?
Goes to the network.
It goes to the network,
Delete from the cache first.
delete from the cache first. Let's say kind of, and a no. It's not going to delete it from the cache. And it's going to the network, but not for what you're expecting. It's making what is known as a conditional request. It will say, hey server, for that CSS file I have a version. And what do I do with that? And the server can respond with not modified. That means the file you have is okay, go ahead with that. Here in the server we didn't change it, so let's keep it. And it can attach updated cache headers, such as keep it, move the expiration date for 2 months. Or it can say, no, the one you have is gone, so I'm going to repend with an OK and a new file, HTTP 200. Okay? Which seems like not so bad, the conditional request. The problem of the conditional request is that it's waiting an HTTP request. It needs to go to the server. So the overhead for a conditional request is still almost as the same as making the request, the normal request from scratch. So typically we want to avoid conditional requests because it's not adding any value. The idea originally was good probably, but in the real world it's like making a normal request. It takes the same amount of time. We need to go to a server and the whole overhead is there. Okay, makes sense? We need to understand this and then use this in our favor. How? We need to maximize the opportunity of always having the file on users' devices. If we do that, we will improve performance, because performance is about users' perception. Okay, so yeah, the problem is that I know, but yeah, but I have my manager here that she always wanted to keep fresh the data, so we need to push always the latest version just in case we change the CSS with the color. But performance is more important, so we need to find a way to go over that, and there are design patterns to do that. So it's always better to set static resources with a far late expiration date. It will last for 60 years. It doesn't matter. And you're not going to waste users' space because browsers will delete they have their own expiration rules for that, so you shouldn't care too much about that. Okay? Do you have any question about how the browser's cache work?
So I guess just to like differentiate between like caching like passwords and username, like login info, would that really be the only thing that you'd want to have, like a more set?
Yeah, in this case, the browser's cache is a separate storage compared with other storages that you have.
Okay.
If you're interested in how that works and all the storage, I have another workshop on Frontend Masters on storage APIs. So if you check that one with more information about storing credentials and databases and the next, I think it's exactly what we're going to see in a second. There is also a cache that has been with Safari and Firefox for a while, and it has just arrived into Chrome a few versions ago. It's called BF cache or back forward cache. In this case, it's not about resources. It's about saving your page navigation in memory. So you are in frontendmaster.com, you have a session, you have JavaScript loaded, you have done a lot of stuff, and then you go to google.com. Okay, what happens when you go back? We press the back key to Frontend Masters. Normally, it was loaded again, like a new navigation. With BF cache, no, it will just like defreeze that page from memory. And of course, the performance of that is a lot better. When you go back and forward, then you don't need to reload the pages. Okay? In this case, it's automatic, so it's not an API, it's not something that we have to do. But there are some things that you can be doing in your website that can disable BF cache for you. For example, unload events, or a kind of cache known as no store. So you can say to the browser, no store, I don't want you to store the data. If you say that, the browser will disable BF cache for your site. How do you know if that works or not? Using Chrome DevTools, you can go to Application, the Application tab, and within the Application tab, you will find, where is it? They changed it? No, here it is. Within Background Services, Back Forward Cache. So here, because it's localhost, it's not giving you by default any information, but you can test it. So it says that it worked. So you're not using any weird tricks or things that will disable BF cache for your real users. So you can go to your website, make that test, and if there is a problem, you will see a red with a list of problems that you should change in your code if you want to enable BF cache for your websites. Does it make sense? So we're not in control of that. The only thing that we have is the ability to not use some API, so the browser will increase the opportunity for enabling BF cache.
Regarding cache, does adding query parameters after a file name make a difference?
That's a good question. So the cache that we were seeing here, we were talking about here, we didn't see here how the database or the data storage works internally. But what's the key of that storage? Well, one key is the URL, but not the whole URL. There are keys in the method if it's get or post, but let's simplify this only on get requests. It's the URL without the hash. So what's the hash? So the URL has a protocol, has a host, like the origin, it has a path, it can contain a query string, and a hash. Well, the hash is what goes after the pound symbol or the hash. That's not part of the key, but the query string, I think the question was, that part is part of it. So if you have mydomain.com/CSS and then query string 1 and query string 2, even if in the server it's the same file, from a browser's perspective, we are talking about two different assets. Does it make sense? Because it's two different URLs. Even if server side is different. And we were using this technique actually a few years ago when we want to change a file. So it's actually a hack. If you set the expiration date of your assets for 60 years in the future, but then tomorrow you have to change your CSS. So how can you force an update? Well, we go to your HTML and you add like a timestamp or a version number, something like this here, and your users will see a new CSS file, not the previous one, because it's a different URL. Does it make sense? So what goes after the question mark is actually part of the URL, and it will create unique URLs. Okay, cool. Well, if you want to, so how do you know if the user is going out or in the BF cache? Well, you have a page navigation API. With that API, you can know when the user is getting out of your app, and you can open and restore connections, such as if you have a WebSocket, maybe you want to close that WebSocket when the user is going out of your page, and if the user is going back, because it's being restored now, you need to reconnect to that WebSocket. If you want to get deeper on that, check the other workshop on Frontend Master that I also did on JavaScript in the background. We explain and do some examples on page navigation APIs on that workshop. Okay, so service workers and cache storage. So does anyone know what a service worker is here?
It's like a background JavaScript task, I think, that can run.
It's a background JavaScript cache.
Task.
Let's say it depends on what you mean by background. It's not a cache, but the service worker can use a cache. So it's a use case more than what's a service worker. So we have a service worker, and then we have the cache storage. And what you said is the service worker using the cache storage, not exactly what the service worker is. So a service worker is a JavaScript file. I think I have the original definition here, but the service worker, it's a middleware written in JavaScript between your Progressive web app or website and the servers and the cloud. It can be more things. It's actually a different thread. It's a worker. That's why it has its own life cycle. There is a lot to talk about service workers. And I recommend you 2 workshops or courses in Frontend Masters. One from Kai Simpson on service workers specifically, and the other one, the same I mentioned before on JavaScript in the background. We also cover the service workers there. But actually, it's something that you can install in users' devices for your website. And next time the user is visiting your website, the service worker can actually act like the server. In fact, let me make you a quick and dirty definition of a service worker that is not 100% accurate, but you will get it pretty quickly in case you haven't heard about it before. A service worker is a web server written in JavaScript that we install in user's device. So we are creating a web server, and we are installing that web server locally in the user's device, in the phone or in the computer. So next time the user is accessing our website, instead of going to the real server that is in the cloud, that has the latency, because the latency is here. When we are going to the cloud, to the network, that's the latency. If we stay here, we are within the boundaries of the device. We are not going to the network. We don't have the latency. So the service worker is written in JavaScript and can serve files to the browser.
So you can also simplify it down to just being a caching middleware as well?
Yeah, you can. In this case, using that API, you have control of the cache. Instead of relying on the browser's cache, now you can have your own cache and serve your own files locally. Okay. So here you have one use case, one design pattern for using service workers and cache storage. So you have a PWA or a website. Remember, a PWA has a website that makes a request to the server, but there is a service worker installed. So the service worker will say, okay, let me search first in the cache. The cache is a local storage available in the browser. If it's a cache hit, we respond to the browser with that response. If not, we go to the network. So if you think about this, this is similar to what I wrote over the browser's cache. It's kind of the similar algorithm. The difference is that this is written by us. We have control of this algorithm. We write this in JavaScript. And a service worker will not help the first initial visit of your user, but it might help the next visits. Because the next time the user is getting into our websites, we can serve the files locally. It's like a local host on users' devices. Do you have any questions on that? It's a kind of a new paradigm on the web that has been for a while now. Compatible with all the browsers, we are probably 3 or 4 years with all the browsers supporting service workers. But we are still far away from a lot of websites using it. It's still some kind of a scary part of web development, getting into service workers. But it can help a lot performance because it can improve web vitals a lot if we don't need to go to the network every time. Of course, there will be a lot of use cases where we still need to go to the real server and the network.
So it's not sending like just a more compressed version to the same network, it's just not even touching it at all?
It's not even touching the network. And that's why using Service Worker, it's an API that will let you make an offline web, an offline capable web. Because then even if you don't have connection, you can still serve the files locally. Okay, so it's a huge deal. That's why you have here at Frontend Masters a full course just on service workers, and there are other also courses that are taking that topic. Okay? So, two other things before actually starting to analyze how to improve performance, now that we understand roughly how everything works. Typically, let's simplify a website a lot. We have HTML, we have JavaScript, and we have CSS. Okay? That's the minimum. What I'm not sure if you know is that CSS, let's start with JavaScript. JavaScript blocks parsing by default, which means the browser is reading the HTML. If the browser encounters a JavaScript, it will stop parsing. So it will not read the rest of the HTML. Let me show you this in action. In our front-end museum example, when you look at the HTML, parsing is about reading, let's say, line by line and analyzing the code, understanding the elements, and creating the DOM, the document object model. Well, here, for example, on line 4, it gets into a script tag. Well, because there isn't a script tag, it will block the parsing. So it's not going to read the meta or the rest of the HTML until that JavaScript file is downloaded and executed, which is pretty bad for performance. In the network layer, let me refresh so we can get the full waterfall. Let me get off of the screenshot so we have more space, like so. We could see at some point, I'm not sure if it's easy to see here, but maybe here, that logo PNG file was not downloaded. It didn't start the download process before the script finishes downloading. Can you see that? So that's typically a case of a problem like this. For example, if I open my index.html and I have more scripts, like so, I can even add the hack like this, you will see how performance gets worse and worse because it will wait first for this one. It's not going to download more files in parallel. It will go in sequence, one by one. That was 10 years ago. There was like a best practice in web development that was saying, move all your script to the end. Have you seen that? That is because let's defer that to the end so we don't block the rendering. Okay? Anyway, we will get into that in a second. So JavaScript blocks parsing. And rendering goes after parsing. So if we are blocking parsing, we are also blocking rendering. We are pushing rendering. CSS blocks rendering, which means the browser will never render a pixel on the screen if all the CSS that is known at that moment was not downloaded and parsed. Even CSS that is not going to be applied right now, or even if the CSS has a media query and the media query is currently false, it's going to download everything, it's going to parse the CSS, and at that only at that moment, it will start rendering things on the screen. And we know that most of the core Web Vitals has to do with rendering, with seeing things on the screen. Does it make sense? So we need to improve this. Okay?
Can I ask there was a service worker question
Yeah.
that came in late? Yeah, just leave that slide up. That'd be perfect. Why do you think the adoption of service workers has been so slow?
I think the adoption of service worker is slow, first because it's a new paradigm and it changes the whole scope. It's also it's also not simple to implement actually. So it's a low-level API. So you actually need to understand what you're doing or use a library. In fact, Workbox is, for example, one of the libraries. I still find myself getting a lot of developers that don't understand. Maybe some of you, you didn't know what, I mean, you know that they were there, but I don't know exactly what that is. Okay, I haven't used it. So because it's so different from what we were used to use in the web space, it's a completely new paradigm. I feel it's one of the reasons of why it's still slow. Also, debugging with service workers, it's really painful because now you're not hitting directly the server all the time. So sometimes you don't know which version you're rendering is the one that is locally on the. I mean, you can control that, but it feels like it's not so simple as with just files on my server that users are getting, and that's all. It's like you are creating copies of your server on millions of users, and you feel you are losing control of what's going on there. So it's hard work. Yeah, that's probably one reason. Well, and the last thing is frames and interactivity. That is just showing you this particular slide diagram that has to do with animation. So after the page was loaded, the browser has an animation loop. Even if nothing moves on the page, there is an animation loop. When you scroll with your finger, with your phone, you scroll, that's an animation loop going on. So there is always an animation. And the animation renders a frame, and then it analyzes input events. Input events is, have you scrolled? Have you clicked? Is your mouse over something? So every event that you have in JavaScript can be an input event. After parsing those events, and that's actually your code, your JavaScript code, when your JavaScript code releases the thread, then the browser parses the HTML, styles and layout in case you have changed something or in case you have moved the page and there is something else that needs to be analyzed. Then it goes into paints and composite, and maybe there is an idle time before the next frame. And it's doing that, for example, 60 times per second. Okay, that's the idea. The problem is, what happens if your JavaScript code is taking a second to execute? We have a problem because we are pushing the rest because it's only one thread. So that means the animation will be bad. You won't get 60 frames per second, and you get into performance penalties. Okay, so this is just, again, just how the browser works. Okay, any question? No? Well, now we finally start talking about, now that we understand how everything works, how important performance is, it's time to start optimizing performance. So first, basic things that you have to check. We need to enable gzip on text-based files. This is typically happening everywhere, but yeah, if you are setting up your server yourself and you're not using a cloud-based service, a GitHub, or I don't know, Vercel or something like that, maybe you have to check how it's set up. I'm pretty sure that for HTML, CSS, and JavaScript, you are serving those with zip. But what about SVG? What about APIs and JSON? Because that's text also. You don't want to compress JPEG files to font files. No, just text-based files. Okay, this is very basic. Okay, it is from the beginning of web performance. But just have in mind that you are doing this, and you are. How do you know if your server is doing that? Well, Lighthouse, the tool that will give you the score, will give you a hint. But if not, you can just click on any text-based file here and check the headers. In the response headers, you can check if it's compressed or not. And also you will see in the request that the browser is accepting gzip, deflate, and we don't know what that is. I will explain what that is later. Okay, so that's how you check if it's compressed or not. And you can also see that on the main HTML file. Okay, so looking at the headers, you can detect that. We have already mentioned this, make static content expire late in the future. I know it sounds scary, but for those of you that are creating React applications, Angular applications, you are already doing this. I'm not sure if you know that, but sorry. If you have your app.js, your bundle.js, that the output of your React application typically has a hash. Have you seen that? It's not app.js. It's app.059d8.js. Why? Because every time you change the build process, there is something new in the build, you change the hash. And why is doing that? The idea is to make all that files expire late in the future. Because if you change a bit, you know it's going to be a different file name, a different URL. Use a CDN for static content. This is all, but the CDN will actually get closer to the user. So the CDNs, they have mirrors all over the world. So then it will serve your content closer to the user. So the latencies will be shorter, and that will lead to better experience. You can see that so far, these are not yet things that have to do with front end. It's more about the server. And yeah, there are a couple of, the first thing that we have seen are more related to the network layer, to infrastructure, to settings in your servers. Well, consider moving to HTTP2. You must move to HTTP2. We know that. Cookieless domain. Do you know how cookies work? Cookies on web development, right?
Stored in local storage, right?
They are being stored on local storage, yes. And what else? First, are cookies client side or server side?
They live on the client and tell the server status about the client's browser?
Correct. So they live on the client, but both the client and the server have access to them. How? How the server knows what you have on the client?
You gotta send it there.
You have to send it. How? Who is you?
I mean, the browser.
The browser or
sends,
the developer?
the browser would have
The
to
browser. The browser sends cookies to the server on every request. On every request, it sends all the cookies. So for example, if you have cookies storing 2K of data, and then you have a website with 50 assets, you will send 50 times over the uplink 2K. 100K of data that you are sending on every request, even if you're not using that cookie on the server. So using cookieless domains means that for your assets, it may be a good idea sometimes to create another domain. Maybe it can be also CDN that will help you, will give you a different domain. And that CDN will be cookieless. So the cookie won't travel to the server. Does it make sense?
Can you set up the cookies so that there are some that don't always send to the server as well?
Cookies by default are sent per origin.
Okay.
So every request, you can set an expiration date, so it can expire, but you cannot say, I want cookies so only for that HTML. No, it's per origin. So all the origin will get all the cookies. Anyway, cookies are maybe getting away in the future. So they have problems everywhere, so try not to use cookies. But anyway, have that in mind. Even if you have cookies, try to reduce cookie size. For example, this is delta time. If your cookie is 3K, it might add on HTTP 1.1. On HTTP 2 it's a little better because it's compressed. Remember, the cookie goes in the header, and HTTP 2 is compressing headers. On HTTP 1.1, it was adding 78 milliseconds per request. Per request. Okay. This one is interesting. Reduce redirects. So a redirect is a stop sign. Okay. And for those of you in different countries, I'm using the definition of a stop sign of US, Canada, and Europe, because there are many countries where the stop sign is mostly a suggestion of a slow down. Okay, no one actually stops here. In Argentina, we don't stop. There is a stop sign, but actually you don't stop. It's more a warning, be careful, than a stop. Anyway, so the stop sign here is the one where you actually stop, see, both ways, and restart. Okay. When you have a redirect, that's what's going on. What's a redirect? You go to a website, and the website says, oh, you know what? It's not here, it's there. go there. So remember that all the process that we mentioned that we have when we are browsing the web, when you make a redirect, at one point, actually here, the browser says, oh no, it's not here, we need to go somewhere else. So it starts again from 1 to 7. And there are situations where can be really complicated. I remember one airline, I'm not going to say which airline, but let's say AA.com, just a generic airline, that they were doing this. You were on a mobile device, you were going to AA.com, and they were saying, oh, you're on an iPhone or an Android, you need to go to mobileaa.com. Then when you get there, when your browser gets there, they were saying, oh no, it's mobileaa.com/default. And then it's mobileaa.com/page.asa, something like that. And then, probably /default. Actually, and then you say, oh, but no, you have an iPhone, right? No, we have a special version for iPhone, not that is just for iPhone. So it's iPhone blah blah blah. And the problem is that every redirect it's a stop sign, and we start again. We stop, we start again, and the user is seeing nothing in the meantime. Makes sense? So we should avoid redirects. And sometimes you have redirects that you don't realize. For example, if I type frontendmasters.com, maybe it redirects to www.frontendmasters.com. That's a redirect. www is another DNS query. So we also have a DNS query that was taking 150 milliseconds. So then you have 150 milliseconds of, let's say 100, of DNS. Then 150 of TCP. Then, let's say, let's simplify 150 for SSL. And then I need to do this, and then the HTTP request. Finally, to realize that it wasn't there, so I need to start again. And we haven't seen a pixel yet. So we need to avoid redirects as much as possible. And the redirect looks like this. The redirect is pushing all your diagram to the right, and with that, all the metrics. Does that make sense? So each redirect will consume between 100 milliseconds and 1 second. It depends on the latency, and it depends on if you are redirecting to the same origin, or if it's a different domain, a different origin. So there is a lot of possible differences there, but it's really, really expensive. And also social networks will typically use one. So such as bit.ly, t.co, when you're publishing on Twitter. So that's a redirect. You don't manage that, but you know that there will be one redirect when at least don't add more on your own side. Typically there is a question, oh, but I need to go to another server because I first detect the language and the country based on the country. Well, do that server side. Don't send that path, that navigation path to the client. Find a way to do everything within your boundaries, and then just answer with the HTML the user wants. Don't send HTTP redirects. Okay, make sense? They're really, really expensive. Well, remember we mentioned CSS as appetizer. CSS should be small and as soon as possible. In fact, in our code, let's look at our code. Let me close these things I have here. Index.html. I start with the script. I will solve the script problem in a minute, but that's wrong. The first thing I need is the style sheet. So I should move both style sheets to the top before anything else. So I want to help discovery, and I want the browser to discover my CSS file as soon as possible. Why? Because the CSS file will block render. I know that the browser will need all the CSS files to render anything on the screen. So I don't want to make a late discovery. I don't want the browser to discover this late when it's late. Okay, make sense? But that's for CSS. Also, if I analyze what's going on here, I actually have 3 CSS files. Style CSS, one that comes from Google, and background CSS. And you say, okay, why background CSS? Look at this. Why background CSS? It's this one. It's difficult to show you this without the hovering. This one, why is not downloading really fast as the other two? So if I have a style CSS here, it's starting, the download process starts here. But background CSS takes a while. I want to push this back. Why? Do you see the red line, the vertical line? That vertical line doesn't happen before that CSS file, because we know that the browser will never run the pixel if all the CSS files were downloaded and parsed. And if I can move this somehow that way, maybe I can move that line as well. And it's not about the line, it's about the metric that will improve user perception and that will improve conversion. Okay, remember that. So what's going on with that background CSS? Well, if we look at the code is just adding styles.css, but when we get into styles.css, it's importing the background CSS file. Because some designers prefer to do that, so they separate the CSS file, like in several per topic or per section, but this is pretty bad for performance. Why? Because we have to wait until the browser downloaded and parsed styles.css file to actually realize that there is another one to download. So we have late discovery. The browser discovered background CSS late. Does it make sense? So we don't want that late discovery for our CSS. So don't use add import. So here we can just copy and paste the CSS into one file, or if you want, on HTTP2 it's not going to add a lot of problems to add background CSS here. So we have early discovery. Later today we will see how to improve that in case you cannot do this. For some reason, let's say for some reason that CSS, the name of the CSS, we know that after some execution. Well, we will see how to solve the problem. So now if I refresh, I should see a difference on loading CSS files, that now background and styles are being downloaded in parallel at the same time, not in sequence. Can you see that? So then we are letting the browser know all the CSS as soon as possible. Make sense? We still have some problems with JavaScript. Okay, we will get there, because JavaScript should be deferred, as I mentioned before. So we need to defer JavaScript as soon as possible. So because JavaScript will block parsing, and it also uses the main thread, the same main thread that is used by the browser to lay out, composite, and make all the stuff. So first, remove or defer unused code. So I remember a research that found that typically 20% of the JavaScript file is not being used ever. It's like orphan code that you have there in your JavaScript file that is not going to be used, but it needs to be parsed anyway. And JavaScript is the most expensive asset that you have in your website. It's not because of the file size, because maybe JPEG files can be larger. It's because of the CPU cost, because we have to compile the JavaScript code. So there is a just-in-time compiler in users' devices, and parse and compile that JavaScript and then execute that JavaScript code. And that's typically 1,000 times more costly than a JPEG. Okay, so that's why JavaScript is so important. And how to do that? So how to defer JavaScript code? Well, we need to convert our script tags into non-blocking script, because by default, when you have blocking scripts, you will see things like this, like a stair. Here in the diagram, can you see that there is like a stair? But you don't see any other parallel downloads. You just see one 1, 1, 1, and then parallel downloads. When you see this in your waterfall chart, that typically means you have blocking scripts. In this case, we have 3 scripts. The first one is HTML, and then script, script, script. That's because we already mentioned this, but by default, we have HTML parsing here going on. Here. The HTML is parsing, and it finds a script. And it says, oh, there is a script. OK. We do nothing else. We post parsing, we post everything else. We download the script and execute the script, and then we continue. And that's wrong. We don't want that. That's why HTML5 supports now the defer attribute. If you use the defer attribute, it will download the script in parallel with the rest, and it will wait for the HTML to end parsing to execute your JavaScript. That's defer. And then you have also async. That async will download in parallel, but it will try to execute it immediately as soon as possible, pausing the parsing for a while. If you don't know which one to use, you should use defer by default, and let async only for one. It's a very specific case, such as analytics, and it should be really, really short, because you are still harming performance of your parsing. So in our example, we can go to the script. We don't need to move the script to the bottom of the body. That was an old trick. No need to do that. You just need to add the defer attribute. It's a Boolean attribute, and that's all. So now that JavaScript code, it's not going to block the parsing. Have in mind, your JavaScript code won't be executed until the body ends parsing, actually. Okay, so it will take more time to execute that code. By the way, we are still on basics. These are basics of optimizing performance. Compress and obfuscate JavaScript and CSS. This is still valid on HTTP 2. Compress is going through a compression tool and obfuscating the JavaScript and CSS. So it has been proven that if you do that, you may still improve the file size and transfer by around 10%. It's not mandatory. I mean, it's not one of the things that will change your life in performance, but every small thing counts. I remember a joke from a web performance engineer saying that we as web performance engineers, we are counting milliseconds as top models are counting grams. Okay? Like saying that we are counting milliseconds, and for us milliseconds are really, really important. Okay? Anyway, it's time for a tech break. So let's take a break. 5 minutes, 10 minutes?
Let's take a 10 so people.
10. Okay, 10 minutes.